Hello and welcome to another GCSE revision video, and in this video we're going to be looking at pictograms. Now, bar charts can convey both frequency and relative frequency, whereas pie charts only convey relative frequency or proportion. Pictograms convey the same information as bar charts, but done well can seriously spice up your presentation. Nobody likes to sit through a boring presentation, and if you keep using the same kind of chart, then your audience will feel bored and stop listening to your presentation. And even if they politely sit through the whole thing, their mind will have wandered elsewhere. Here's an example of a pictogram where the little pictures of birds represent one bird, and these are the same hypothetical birds that visited my hypothetical garden that you might be familiar with from my other videos. So we've got 3 finches, so we've got 3 little pictures of a bird. 3 pigeons, so we've got 3 pictures of a bird, and so on. It's just a way of visually representing this data in a slightly more appealing way perhaps than a bar chart. Now, a pictogram will pretty much convey the same information as a bar chart would. The pictures just represent the frequency, only you can't read it off the y-axis, so you need a key to tell you what the pictures represent. Done right, a pictogram can seriously spice up your presentation. Now, you can be as artistic as you like. In fact, it's a great excuse to actually be a little bit artistic when you're doing a pictogram. But don't spend too much time on it. Remember, this is a maths exam, not an art exam. In fact, you don't have to make the pictures look really beautiful. You can have simple shapes like triangles or circles if you like. Now, of course, you're not limited to one picture represents one thing. You can have one picture representing 5, 10, 50, 100, 1,000, a million things. You could also have a different picture for different categories if you like. And you can be as artistic as you like making your pictures. However, as this pictogram shows, you can have too much information. Remember, the whole point of these graphs is to show people the big picture. If you're going to get bogged down in the details, you might as well just hand them the raw data. It's no help. In this case, what's wrong with this pictogram is that there's so much detail in it that it's only conveying the same information as is already in the frequency table, except that the pictogram is harder to read. So we've put an awful lot of effort and work into something that's less useful than the thing we started with. That's pretty much the definition of being counterproductive. Okay, so here's a better example of a pictogram. Okay, some of the data's been lost. For example, the 2 that failed don't even show up on the pictogram because the numbers have been rounded off to the nearest 25. But it's much clearer to see the distribution of the data. If someone were to ask, what grade did the majority of students get, you can answer that question very quickly just by looking at the pictogram. You might have heard the phrase looking for a needle in a haystack. Well, the purpose of your pictogram, and not just a pictogram, but the purpose of all of your graphs and charts, is to get rid of the haystack so that people can see the needle. Okay, so much for the theory. Let's have a go at putting this into practice. I've lifted this from a GCSE question. It says the table shows information about the number of fruit trees in an orchard, and we've got 45 apple trees, 20 pear trees and 25 plum trees. Part A says the pictogram shows this information. Complete the key for the pictogram. As we can see, we've just got nice simple little triangles that represent the number of apple trees, and we want to know how many trees these triangles represent. Well, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 triangles to represent 45 apple trees. Okay, well, I know from my times tables that 9 times 5 is 45, so I strongly suspect that one triangle represents 5 trees. And just to be absolutely sure, there are 1, 2, 3, 4 triangles to represent 20 pear trees, and 4 times 5 is indeed 20. And just because I'm going to be absolutely paranoid about possibly making a mistake, I'm going to go with the plum trees as well. There's 1, 2, 3, 4, 5 plum trees, and 5 times 5 is indeed 25. So I'm now triply certain that one triangle represents 5 trees. But that's the general idea of pictograms. It's just a nice, simple way of representing the data. Okay, I hope that was helpful, and I'd like to wish you all the best with your revision and all the best with your exams, and I'll see you in a future video.